Good afternoon, everybody. In my presentation, I would like to describe characterization of cannabinoids in hemp products from analytical point of view, starting with hemp products or whatever it is, following the analytical procedure, which is presented here like a starting point is sample. Then we have analytical procedure with usually chromatographic or spectroscopic techniques, and many results are formed after the method. And this data was important from medicines to treat patients, especially if are the child patients. And some health risk assessment is needed also in this case. Generally speaking, about analytical chemical analysis, we have, let's say, three steps of analysis. Analytics, which including many different sample preparation techniques. The next step is analytical separation, analyte separation, which include gas chromatography, liquid chromatography, other techniques which are possible for separation of mixture of compounds into the separated compounds, and finally detection of analyte, where are mostly spectroscopic techniques included in these measurements. The same procedure is described on this scheme, where we started from a sample. After treatment of samples and purification, cleaning, and separation, we have again results of our complete analysis of cannabinoids in this case, but in generally of any analyte which is done for analytical procedure. In the case of chemical analysis of hemp products, I have to emphasize a lot of challenges which are appear in this case, where we have very complex material or matrix, which from pure plant and dry plant materials to oils, resins, waxes, tinctures, food additives, and other things which are usually the form of sample which we examine in our let's say in our cases. Separations are techniques which are also different. Usually are important chromatographic techniques in many ways, and of course extractions. There are also other ingredients or impurities in a matrix, because the matrix is complex, and we can expect some other compounds also. Some of them are described here. In the case of chemical analysis of hemp, we are orientated on mostly cannabinoids, which are mentioned before, and some of them are more important and find in a bigger amount or larger amount. Some of them are present in a traces, and approximately 100 or even more cannabinoids are found in this kind of samples. And most important are THC and acidic form of THC, and also CBD and CBDA. And there are also some others which are usually found in hemp products. In the case of chemical analysis of these compounds, we use two techniques, gas chromatography, mass spectrometry, and liquid chromatography, mass spectrometry techniques. Both are somehow exclusive, but some of points of these techniques are the same, and the results are usually the complete form of using both of techniques. The gas chromatography, mass spectrometry is techniques when we use agilent triple quadruple mass spectrometer for detection of compounds, and gas chromatographic separation technique of gas chromatography for separation of compounds on particular. And this gas chromatography is shortly presented on this scheme when separation was done in a chromatographic column and injection of sample is the sample is injected to the injection port in a gas phase. After separation, separated compounds are formed on a detector, which chromatogram is presented here. This is a general chromatogram of separation of solvents, and but the same is happened also for cannabinoids. The other technique which we use for hemp products is liquid chromatography, mass spectrometry separation on a liquid chromatograph and detection on high resolution mass spectrometer, which we used for our work, and the results will be presented later. And this is only a photo of the instrument in our lab, and this liquid chromatography technique is described on this slide, when we have two options of using ultra performance liquid chromatography on HPLC, ordinary HPLC. Difference is mostly on the time of separation. The retention time is shorter in the case of UPLC, when the higher pressure is used and particles of the stationary phase is smaller, and that's the reason why the separation is faster. And then after that injection from HPLC or UPLC goes through the electrospray ion source, and after mass chromatographic separation, we have finally on detector separated compounds which are characterized with mass spectrometric measurements. This means molecular mass usually is elucidated, and determination of elemental composition is also possible, and similar things with the high resolution mass spectrometer. Starting from LC MS chromatogram, we can find the result of particular peak in a mass spectrum, and after that also MS spectrum are obtained, where we have additional informations about products which are formed in a liquid chromatogram. For each peak, we can observe their own MS spectrum and MS spectrum. Let me show the chromatogram of GC-MS measurement of standards, which are used just for impression to see how chromatographic resolution is obtained on parameters which are described here. So the separation is fine. The chromatographic time is about 15 minutes, which is quite a long one. And using LCMS, we have a shorter time for the same internal standards, or for the same compounds, standard mixture of cannabinoids. In 7 minutes, the measurement is finished. The results of LCMS measurement of hemp oil sample, we found some cannabinoids in complex samples. We can see many other peaks also, which are not a part of cannabinoids, but are other compounds like fatty acids, terpenes, and so on. These compounds are also measured and described with high-resolution mass spectrometric measurements. But first, we would like to see our molecular masses of THC and CBD. The quantitative ratio between those two compounds are obtained from the same or from the previous LCMS chromatogram. Integrated of those two peaks shows the ratio between CBD and THC, which is the first our goal in these measurements to measure THC CBD ratio. In this case, is about 1 to 11, and in some cases, our results completely different. Depend of what kind of sample we have in a chemical procedure. With high-resolution mass spectrometric measurements, we can describe also elemental composition of CBD or THC, and it's the report of HRMS measurement is presented on this slide. We have a composition of elemental composition of the compound, which are measured on a let's say accurate scale of 4 decimal places, and after this measurement we can quite precisely and accurately shows the composition of elements and somehow characterize the compounds which are measured. The same is possible to measure for other impurities or for other compounds which are included in a LCMS chromatogram. Since hemp products is very complex matrix, many other natural compounds can be present, and we used also MSMS measurements for finer or for further characterization of matrix or compounds in a matrix. And in this case, we use collision-induced dissociation of molecular ion, like in this case 313 for THC, and the MSMS spectra show us typical product ions, which are also like a fingerprint of compounds, and for elucidation and characterization of this compound is confirmed on this way. Of course, exists also much more simple and fast analytical methods for detection of cannabis products, but most of them are not so precise, accurate, and specific. Some limited values are included in these techniques. So anyway, standard methods are usually GCMS and LCMS. From summarized, I can say that methods which was primarily used was LCMS methods, which is fast enough and quite accurate for determination of first THC and CBD order, and also other cannabinoids are then determined. Also some impurities which are found in hemp products. This was used for hemp products was used for alternative medicinal treatment, and the information of THC-CBD ratio in hemp products is in a higher level, which is important for medicinal and therapeutic purposes. In the case of child patients, we have to be care about psychoactive THC compounds, which could be low as much as possible, and the level of CBD, which is desirable for medicinal effect. And according to SAMS measured results of cannabinoids in hemp and hemp products, the suitable treatment and therapy is prescribed. Of course, this was past presentation to go through my job, which I worked in coordination with pediatric clinic, and I hope this was for today's presentation enough, and we understand each other much better after this all presentations, which and I am really enjoying these lectures which I heard, and hopefully you too. And that's all for my side.
I would just like to ask you, what would be the best method for determination of this analysis of CBD and THC in blood or in some other specimen, like urine or saliva or whatever?
Of course, there are even more complicated matrix. Blood samples or serum sample, biological samples are much more rich of different compounds, and separation steps is more difficult. Sample preparation, it needs special equipments and special procedures, more than in the case of hemp products, which are shown here. And this is so another additional steps for sample preparations which are needed, but in generally LCMS or GCMS techniques are used for this determination anyway, also in blood samples. You need some more experience with human matrices. We used our instruments mostly for environmental detection and determination of environmental samples, traces of impurities or pollutants in environment, and other laboratories which are more oriented on the human samples maybe can develop also the method for these plasma samples and similar samples, or urine samples. And we can expect more metabolites of cannabinoids also in this kind of samples, and but all of metabolites are usually known, so we can be orientated on these products too. So the analysis will be targeted anyway. It's not so unknown, but the method should be developed anyway.
The problem with using urine and blood samples is the amount in the sample. This is the basic. So most of the world using HPLC to detect CBD and THC. From blood sample, the amounts will be undetectable. And as the professor said, the LCMS and GCMS are the methods to do that. It's needed to do a different sample preparation, and to know how to work with the different. But people are doing it for years, to check drugs in the blood, every toxologic department in police. That's what they know to do for years. So this is to analyze THC and CBD. It's not a big problem. To analyze all other compounds, to understand the derivatives, and to understand everything, it took us a lot of work to do that. But it's doable, and the equipment is the equipment that's just been shown, the LCMS and GCMS.
Thank you.